Okay, hello, good evening students. And in just previous lectures we are just discussed we are connected the registers in a series form. When we are connected the registers in the series form, the current of each registers will be same and path of each registers will be same. And in these lectures we are registers connected in a parallel combination. Then parallel combination of resistance. Parallel combination of resistance. The resistance are connected in a parallel form. I will be give you just one of the clue how we are connected the resistance in the form of parallel or parallel combinations. In a parallel resistance, the same voltage will be applied across each registers. In parallel combination, in parallel resistance, the same voltage apply across each resistance, applied across each resistance. In the previous lecture or in the previous content, we are resistance are connected in a series form, then the voltage will be different in when we are connected the resistance in a series form, but in this term will be different when we are connected some resistance in a parallel form. Then the applied voltage will be same and current is different, but the path of each resistance is different. Okay, now I will be drawn one of the diagram of the circuit diagram, for I will be show you how I will be connected the resistance in the parallel form. Connected in the parallel form. This is the diagram, and these are the two resistance I will be connected here. That is, this is the R1 and another one is the R2. Two resistors are connected and the potential difference between two resistors, that is V. This is not a circuit diagram. I will show the potential difference between two resistors, and potential difference of each resistors will be same. The current is different and path of the resistance is different. Consider the positive and negative charge, the current flowing from this path, and for the resistance, the path, the resistor 1, the path of the current will be maybe this form. The path of the current is this form. Path will be different for the different resistance. Then there are changes at that point. This point consider A. At the point A, the path of each resistance will be different, or from the point A, the path of each resistance is different, then path of each resistance is different. This is the second point I will be give in this parallel combination of resistance. And third form, the current will divided, or the total current, in parallel combination is divided in I1 and I2 for the resistance R1 and R2 respectively. Then the current will be divided. The current I1 for the resistance R1 and current I2 for the resistance R2. The current will be different when the resistance are connected in a parallel form. The current will be same when the resistance are connected in a series combinations. And the potential difference is different when the resistance are connected in a series combination. The potential difference will be remain same when the resistance are connected in a parallel combination. These are the comparison between the resistance will be connected in a parallel and series combinations. Now, the potential difference is the same for both resistance. Then according to the Ohm's law, I will be use the Ohm's equations and calculate the equivalent resistance for the parallel combination of the resistance. In the previous lectures, I will be also use the Ohm's law, but the total current I is equal to I1 plus I2. The total current in the circuit, the I is equal to I1 plus I2. According to the Ohm's law, then V is equal to IR and I is equal to V divided by R. This is the both are Ohm's law and rearranged equations of the Ohm's law. Then for the I1, then I1 is equal to V upon R1. The potential difference is remains same for the both resistance. For the I2, V is equal to R2. Why I will be find the I1 and I2? I will be use the equation for the total current and calculate for the total current. I use the individual current equations. I'll be drawn here. Then the total current I is equal to I1 plus I2. Then V upon R1 plus V upon R2. This is the I1 and this is I2. We know that I is equal to V upon RP. I is equal to V upon RP, and RP it is the equivalent resistance for the parallel combinations of the resistance. Then I is equal to I1 plus I2 by the equation number 1. Then I is equal to V upon RP is equal to V upon R1 plus V upon R2. The potential difference for the each resistance when they are connected in parallel combinations remains same. Then V upon RP is equal to, I will be take the common of V. Then for both equations, 1 upon RP plus 1 upon R1 plus 1 upon R2. When we are observe these equations, we are cancel of potential difference V for each terms or V for each sides, that left hand side and right hand side. Then 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. This is the equation to find the equivalent resistance for when the resistance are connected in a parallel combinations. Then from this equation, the reciprocal of equivalent resistance is equal to the sum of reciprocal of each individual resistance. Again, the reciprocal of equivalent resistance, that is Rp is the equivalent resistance. Then the reciprocal of equivalent resistance Rp is equal to the reciprocal of each sum of each individual resistance. This equation for only parallel combinations of resistance. In a series combinations, I will be write at that side Rs is equal to R1 plus R2. This is the equation I will be use when I will be consider or I will take the resistance in a series form. But when we are take the n number of resistance, we take the n number of resistance in a parallel form, then 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus that is I will be use summations I goes from 1 to n number of resistance, that is 1 upon Rn or Ri. This is the equations of, we take the equivalent resistance when the resistance are connected in a parallel combinations. We are just discussed comparison between two different types of the connections when we are connection or we are combinations are series resistance or series combination of resistance and parallel combination of resistance. In series combinations, the resistance are connected in a same path, but in parallel combination the resistance are connected in a different path. In a series combination, the current of each resistance will be same. In the parallel combination, the potential difference of each resistance is same. In a series combination, the potential difference of each resistance is different. In a series combinations and parallel combination, the potential difference of each resistance will be same, but current will be different. And I will solve one of the problem. I will calculate one of the problem for the remaining of these two equations or these two formula for the equivalent resistance. I will use of same diagram now. You know that what are the equations for the series resistance and parallel combination and series combinations, and how to calculate the equivalent resistance or total resistance. Then I will be connected three different resistance in here. Two are in a parallel combinations, one is in a series combinations of these two. Then this is the R1, this is the R2, and the remaining one is a R3. calculate the total resistance and total current flowing through the given circuit. And I will be asked how to calculate. This is the R1, this is the R2 and R3, and one another terms will be given here. Given R1 equal to R2 equal to R3 and V, total potential difference. Then R1 is equal to 3 ohm, R2 is equal to 6 ohm and R3 is equal to 10 ohm. This is 6 and this is 3 ohm, this is 6 and this is a 10 ohm. And they gives one of the difference, that is 20 volt. 20 volt is a potential difference. How can I calculate the total resistance? Then before the calculating the total resistance, I will be drawn the equivalent resistance for these two parallel resistance. पहिल्यांदा या दोन पॅरलल रेजिस्टन्स इक्विव्हॅलंट रेजिस्टन्स काढून घ्यायचं आहे, देन त्या इक्विव्हॅलंट रेजिस्टन्स मध्ये ह्या रेजिस्टन्स ऍड केल्यानंतर आपल्याला टोटल रेजिस्टन्स भेटतंय. म्हणजे टोटल रेजिस्टन्स that is R of T, total resistance RT is equal to RP plus R3. This is the equivalent resistance between these parallel connections is RP and another remaining one is R3. Then RP is equal to, then 1 upon RP, I know that this is equations, 1 upon RP is equal to 1 upon R1 plus 1 upon R2. Then RP I get the numerator to take reciprocal of this and multiply of this, that is RP is equal to, या दोन्हींचं cross multiplication, that is R1 into R2 divided by addition of this R1 plus R2. We know that the value of R1, value of R2, and I will be calculated RP. RP is equal to R1 into R2, 3 into 6 is 18 divided by 3 plus 6 is 9. Then RP is equal to 2 ohm. This is the equivalent resistance for the parallel combinations. And the total resistance RT is equal to RP plus R3. Then RT, total resistance RT is equal to, that is RP is 2 ohm plus 10 ohm. This is the R3. Then RT is equal to 12 ohm. This is the total resistance of the given circuit, and I will find the total current according to the Ohm's law. Using the Ohm's law, V is equal to IR, then I is equal to V divided by R. This is the total voltage, total potential difference across the given circuit, and these are the total resistance between the given circuit. Then the total voltage is a 20 volt divided by the total resistance is a 12. Then the total current flowing through the given circuit is I is equal to V upon R, that is V is 20, 1 point, that is 66, 1.66 ampere is the total current flowing through the given circuit. And in these lectures we are just discussed the parallel combination of resistance and get revise or comparison between the series combination and parallel combination of the resistance, and we take one of the problem, we solve one of the problem for the study of both series combination and parallel combinations.